Please can you move the box on the right down a little bit? Thank you. So sine 2x is like sine 2a. So it will be sine 2x equals 2 sine x cos x. And then cos x equals 3 over 4. So times 3 over 4. And,
any idea how you can find what sine x is?
do 2 times 3 over 4.
Why would you times it by 2?
At the front of the sine x.
So that would tell you 2 cos x.
Oh.
What is cos squared x?
One minus sine squared x.
That's very true. And in this case, what is cos squared x?
3 over 4 squared.
What is 3 over 4 squared?
9 over 16.
Yes.
So minus sine squared x is equal to 9 over 16 minus 1. Which is minus 7 over 16. So sine squared x equals 7 over 16.
Yeah. And so sine x?
Plus or minus the square root of that.
Very true. This is some angle. Is it positive or negative?
It has to be positive.
You would think so.
Oh my god, that's my brother. He's on PlayStation.
What age is he?
12.
Or sounded like a baby or something. This angle is between 180 and 360. No. Sorry. The cos of the angle is between the angle is between 180 and 360. So what do we know there?
That would be either in the tan or cos quadrants. So they would both be negative. Sine would be negative for those.
Yeah. And so what is sine x?
Minus.
Yep.
Root of 7 over 16.
Yep. And so what is sine 2x?
So you just type that in, yeah?
Yep. I love that answer.
I got minus 3 root 7 all over 8.
Nothing wrong with that. Okay. B, tan 2x.
So it equals 2 tan x over 1 minus tan squared x.
Mm-hmm.
So we have to wait, no.
So we have to find tan x.
Sine x divided by cos x.
Boom.
So minus root 7 over 16 divided by 3 over 4.
Yep.
And I got minus root 7 over 3.
Minus root 7 over 3. Let's see, what do you do with her?
Then we sub that into.
Yep.
So 2 tan minus root 7 over 3. And then 1 minus tan minus root 7 over 3 squared.
Sounds good.
Okay. It gives like a long decimal number.
Calculator, let us down. That means we have to do it manually.
Oh.
Okay. Manual time. So, how do we do this manually?
I don't really know.
How do you divide fractions?
Flip change.
Yep.
Okay, so it would.
Yeah, let's simplify both of them separately and then we'll do that.
Okay, wait, so should I type them individually to the calculator?
Yeah, actually, yeah. Try doing them individually in the calculator.
Okay, for the first one, it's root 7 over 3.
Minus 2 root 7 over 3?
Yeah.
Okay, sorry, the call went glitchy.
It's alright.
Yep.
And then the second is 2 over 9.
Yep.
So can I just type that in?
Should work. I thought the first one would have worked.
Maybe I typed it in wrong. Okay, this one gives me minus 3 root 7.
Sounds fine. And press SD, see if it's the same as that decimal. See if you recognize it.
No, it's like minus 7 before it was 5, I think, or minus 5.
Maybe you just mistyped it. Minus 3 root 7. We said sine was minus 3 root 7 over 8. Minus 3 root 7. And this one was minus 3 root 7 over 8. Okay, big picture. They give you cos x. Sine 2x is 2 sine x cos x. We know cos x is 3 over 4. To get sine x, you have to, you can use like cos squared x and then do 1 minus sine squared x to swap between sine and cos that way. Tan 2x, use your double angle formula and then get tan of 1x by doing sine x divided by cos x. Importantly, it is the exact value. If they just wanted an approximate value, you could just do arc cos 3 over 4 and then sine 2 times answer, and you'd get a long decimal. Let me give that a go. So sine of 2 times arc cos 3 over 4. Yeah, so we get a decimal, and my guess is oh, hang on, let me just press answer. Yeah, and my guess is minus 3 root 7 over 8. Yeah, same shizzle. Actually, not quite the same, because remember we said the quadrant is it's these two?
Yes.
Can you be more specific?
What do you mean?
Is it the tan quadrant or the cosine quadrant?
The range is 180 to 360.
Can you be more specific?
Like, you mean choose one?
Yep.
I don't know.
Is it this one?
I'm not sure. I'm confused.
It is definitely this one. X is between 270 and 360. We can narrow it down even more. Do you know how I know?
No.
Cos is positive. It's positive 3 over 4. And
Okay.
which is why I was unsurprised that we got a negative answer for tan, minus 3 root 7. Tan 2x. So we kind of got lucky a bit that calculator told us it was negative. If we were to just do my bad calculator way, a second ago I got positive 0.992. Actually, I should have gotten negative because sine is negative in that quadrant. Any questions about that stuff?
No.
I have so many questions. This thing, hang on. Yeah, there's a little weird thing to that. Let me just see. Okay, that's very similar to that one. Geometric. Okay. Weird time. Okay. Might need this cheat sheet with my formulae. How do we do this thing?
So for this one, does our calculator have to be in radians?
Yeah. Maybe not. Might not make any difference, because if they had phrased this better, they would have said exact value. That should be exact value.
Okay. So we know that cos theta equals 24 over 25.
Mm-hmm.
So then before we did cos squared theta equals 1 minus sine squared theta.
Yep.
So 24 over 25 squared is 576 over 625. So that's equal to 1 minus sine squared theta. So minus sine squared theta is that minus 1. So sine squared theta equals 49 over 625. And then sine theta equals plus or minus square root of that. And then we can use the cast diagram.
Sure.
Wait, so pi is 90, right?
Pi is 180.
Okay, 180. 80, and so 3 times 180. So 180 to 270 is the third quadrant, I think, or tan.
Yep.
So it will be negative for sine, so minus 7 over 25.
Yep.
Then sine theta over 2 is that dividing theta by 2?
It
Or
is.
the whole?
Just theta.
So do we work out like theta equals sine to the minus 1 of minus 7 over 25, and then
That's what you would do if you did what they told you to do, but they were wrong. They should have said exact value. Otherwise, that's exactly what you would have done from the beginning. You're not going to get it. Nobody does. Let theta over 2 be equal to a. And
okay.
so that is sine. Well, so what would you do with that?
So sine A equals minus 7 over 25.
Nope.
Oh no.
Theta divided by 2 is a. So what is theta?
2A.
Yep.
So now we would do sine 2A equals minus 7 over 25.
Mm-hmm. What is cos 2a?
24 over 25.
Over 25. Okay. We have cos theta. Aha. So we have sine 2a. We have cos 2a. So we want sine a. Yeah. What do we do there? So big picture is we want sine theta over 2. Sine theta over 2 is sine a. We're just making our lives a bit easier so there's no fraction. How can we get something to do with sine a?
So we have sine 2A, not sine A.
Yep.
So can you divide both sides by 2? Well, no, because it's attached to the A.
What is sine 2a identical to?
Theta. So to sine A cos A.
And so what is sine A equal to? Because sine A is the same as sine theta over 2. That's what we're aiming for. So make sine A the subject.
From the line above it.
Yep.
So to get just sine A, you would have to divide both sides by 2 and by cos A.
Yep. Okay. What is sine 2A?
Sine theta.
Yeah, it's also minus 7 over 25.
Yeah.
So that's going to be minus 7 divided by 2 cos A. Now we just need 2 cos A. And then we'll get our sine A, which is sine theta over 2, which is what we want. How can we get... We have cos 2A. We want cos 1A. How do we do that?
Cos 2A. Cos 2A is equal to cos squared A minus sine squared A.
Yeah.
So
it's also equal to 2 cos squared A minus 1. It's also equal to 1 minus 2 sine squared A. Which one do we choose? We're trying to find the value of cos A.
not sure.
You choose the one that has only cos. So what you just did with sine, you now do with this one. So sec, it's just pasting. Yeah, pasting way too much. Okay. Cos 2A is the same as 2 cos squared A minus 1?
Yes.
2A, 2 cos squared A minus 1. Make cos A the subject. And you can do it in several steps.
So what do we want? Just cos A just cos A.
Yep.
So cos 2A is 24 over 25. So 24 over 25 plus 1 is 49 over 25.
Okay.
And then divide that by 2 is 49 over 50. And then the cos A will be plus or minus root 49 over 50.
Yes. Which one?
So it's in only tan is positive, so cos will be minus. Minus root 49 over 50.
Yep. is cos A, and earlier we said sine A was minus 7 over 25. We are trying to find sine theta over 2, which we called sine A. When we made that the subject earlier, we said it was minus 7 over 25 divided by 2 cos A, and we just found out what cos A is.
Cos A is minus root 49 over 50. So we sine theta over 2 is equal to I got root 2 over 5.
Root 2 over 5. Root 2 over 10. Let's see. What did you put in your calculator?
Minus 7 over 25 divided by minus root 49 over 50.
49.
Maybe, do I need to put brackets in?
No. Minus 7, 25. Minus 2 root, minus root 2. I'm forgetting a minus. However, I'm getting root 2 over 5. They have root 2 over 10. Let's check our stuff. Let's see. So I took your word for it with this stuff. Cos squared. So 24 squared is 576. 25 squared is 625. So cos squared theta, 1 minus sine squared theta, that gives you 49 over 625. Then we square root that, we get 7 over 25. It is in the tan quadrant, so it's negative 7 over 25. To make things easier, instead of a half theta, I'd let that be A, and so 1 theta becomes 2A, and so it's these double angle formulae. We had to find sine A. We knew cos 2A was 24 over 25. Cos 2A is the same as 2 cos squared A minus 1. Let's see, 2 cos squared A minus 1. We made cos 2A. We knew cos 2A was 24 over 25. So we plus 1, which is 49. Yeah, 49 over 25. Then we divide by 2, 49 over 50. Yep. And then we square root. And we get that. And that is cos A. And so sine theta over 2 is equal to sine A, which we made the subject. Sine 2A we had from earlier. Where was sine 2A? Sine theta, yeah, sine 2A is minus 7 over 25. So minus 7 over 25 divided by 2 cos A. Did we leave out the 2? It should be this times 2. 2 cos A. So minus 2. Okay.
Oh yeah, now we have root 2 over 10.
Okay. There we go. So just when I was transferring it onto the other page, I just kind of left out the 2 cos A. Yeah. But big picture is it's exactly the same as the previous question, except it is disguised because a half theta, if you let that be equal to a, then 1 theta becomes 2a. And so it's double angle formulae in disguise. Any questions there?
No.
It'll be much easier now that you know that little trick. You'll see. Okay. Let's try this. Sorry. Just in case.
So this is 180 to 270. So tan will be positive in that.
Okay. And it is positive.
Yes. Do we let theta equal 2a?
Sure do.
Let theta equal 2a. So then...
Hold on. Okay, let theta be equal to 2a. Okay. Like that, is it?
Yeah, is that wrong?
That's correct.
Okay, so then tan 2a equals 3 over 4, but tan 2a equals 2 tan a over 1 minus tan squared a.
Mm-hmm. What next? Solve.
Wait, solve what bit?
The equation.
So I don't get what we're supposed to do with that.
What's tricky about solving it?
Like, wait, do we know? Oh wait, we know what tan theta is. So we sub in the 3 over 4. Wait, no, can't do that.
We know tan theta, but we don't know tan a. We're trying to solve for tan a.
Oh.
The tricky bit is the fractions. Get rid of the fractions.
So we flip the second one. Oh wait, that's when we're actually dividing.
Cross multiply. Get rid of the fractions. So I just cross multiplied.
Oh, right. Okay, so now we can expand that.
Yep.
So now we have 3 minus 3 tan squared A is equal to 8 tan A.
Mm-hmm.
Okay.
What type of equation do we have?
Oh, quadratic.
How do you
So
solve a
we can
quadratic?
move.
Yep.
So minus 3 tan squared A minus. Oh, wait, should we make that positive, the first bit?
It doesn't matter.
Okay, so minus 3 tan squared A minus 8 tan A plus 3 is equal to 0. So if we just, can we type it in straight into the calculator?
Sure can.
Okay, so minus 3 minus 8 plus 3 x or A equals 1 over 3 or minus 3.
That was what I was afraid of. A is not equal to a third. Tan A is equal to a third.
Oh, right.
And
Okay.
what were we trying to find with this question?
Tan theta over 2, which is tan A.
Yep.
So is that the answer?
You tell me.
Do we have to choose one out of those?
You tell me.
Because it says value, not values. So one doesn't work with negative, does it?
Why is that?
Because it's positive in the tan quadrant.
Well done.
Yeah.
I'm just going to say reject negative answer. Reject negative answer because, yeah, tan is positive in this quadrant. Great. Yeah, I suppose you could say it's outside the range. And therefore, tan theta over 2 equals 1/3. Come on, bookie. As theta over 2 is in the second quadrant, why did they snake me? They've got a point. Theta is in the third quadrant. What quadrant is theta over 2 in?
I'm confused.
Don't be confused. Theta over 2. Divide everything by 2.
90.
Yeah.
2. I don't even know what that is.
3/4. 45, 90, 135?
100. Yeah, I use my calculator.
So between 90 and 135 is this quadrant then. It's going to be in there because that's between 90 and 180. So between 90 and 135.
Yeah.
Haha. So we reject the positive answer. So what's our answer then?
Minus 3.
Yep. So therefore tan theta over 2 is equal to minus 3. There you go. So we have to correct the range. So theta is between 180 and 270. And so theta over 2 is between 90 and 135. And so tan theta over 2 will be negative, not positive. And also, big picture, changing theta into 2a or theta over 2 into 1a is very helpful. From there, you just solve it. It required quadratics. don't forget that when you're solving this quadratic with this trig, a doesn't equal a third, tan a equals a third, and so on. Any questions there?
No.
Yeah, it's just never easy. Okay. This is applying it to geometry. Okay, let's do it.
Do we have to draw a sketch?
Couldn't hurt, I suppose.
So
QPR.
the cosine rule is that a squared equals b squared plus c squared minus 2bc cos a.
Yeah.
So we're using that to show that cos 2 theta equals 5 over 9.
Mm-hmm.
Cos 2 theta, that's like all of those things that it equals. Cos 2a.
So what do we do?
So if that was, we just have, that's, okay, so the little letters, they represent the sides, but except instead of being triangle ABC, it's triangle PQR. So if we change that, so like 5, wait, which one? Cos A, so that has to be cos P. So, okay, so 5 squared equals 3 squared plus 6 squared minus 2 brackets 3 brackets 6 cos 5 cos 2 theta.
Mm-hmm.
And then simplify. So that's gonna be 25 equals 45 minus 2 minus 36 cos 2 theta.
Okay.
So
It's a 3 marker. I think at that stage you could just say, so all I did was 5 squared minus 3 squared minus 6 squared, all divided by minus 2 times 3 times 6. And I'm just going to say that I'm not even going to do that. Yeah, and that simplifies down to 5 over 9 when I put it into my calculator, I'm sure. So I just made cos 2 theta the subject, basically. B.
So we just said that cos 2 theta equals 5 over 9. So we need to change that to sine theta. So we have to use the rule that only has sine, which is the 1 minus 2 sine squared a rule. So, so 2 sine squared a equals 5 over 9 minus 1.
Minus 2 sine squared a equals 5 over 9 minus 1.
Wait, what?
Minus 2 sine squared a.
Oh, okay. So then, okay, yeah. Then 2 sine squared a will equal 4 over 9.
Okay.
To make them positive. And then do we have to divide 4 over 9 by 2?
Yep.
Okay. So 2 over 9 equals sine squared a. So then sine a will equal plus or minus the square root of 2 over 9. And how do we know if it's going to be positive or negative? Cos 2 theta.
Eyeballs. It's a triangle.
Oh, it has to be positive?
I hope so. And so root 2 over 9. I'm rationalizing that to be root 2 over 3. Root 2 over 3. Boom. Is acute. Yeah, must be positive. You got it. Any questions there?
No.
Okay, so now we're applying this stuff to geometry. And this. 1 second. Yeah. Alright. How do we do this?
I don't really know like how to start.
see. Bisects, what does that mean?
Like cuts across.
Okay, so it cuts this in half. Is that theta? And that theta? So what is tan theta?
The angle divided by 2. The whole angle divided by 2.
So the gradient is the rise over the run. Did you ever hear that?
No.
Change in y over change in x?
Yeah.
Okay, how much did y change by? How much did x change by?
1 over 3 over 4.
So it goes through the point 0, 0.
Yeah.
When x is 1, what is y?
Three quarters.
Change in y over change in x.
So change in y is 3 quarters and change in x is 1.
So what is that?
3 over 4. And
tan theta is opposite over adjacent. So the amount that goes up, the change in y, for every 1 across, goes 3 over 4 that way. So the gradient is like 3 over 4. So it's opposite over adjacent. So I think that's it. I think tan theta is 3 over 4. Yes. Whew. It's the gradient. It's the change in y over change in x. Yeah, for every 1 right, it goes 3 quarters up because it's the gradient. Opposite over adjacent is 3 quarters divided by 1. 3 quarters. Tan theta is 3 quarters. Okay. So tan theta is 3 quarters. Find or show that m is 24 over 7.
Isn't m the gradient?
Gradient of the other line. That gets the angle bisected by that line.
So the gradient of that is double the gradient of the red line.
It's double the angle.
Yeah.
And so m2 is tan 2 theta.
What does m2 mean?
Second gradient.
Okay, black line.
Yep.
Okay, and then, so tan 2 theta. Oh yeah, okay. So tan 2 times 3 over 4,
I think so.
which is 3 over 2.
So what's tan 3 over 2?
I got like a long decimal number.
Oh, we could do this thing.
Oh, okay. So if we did that, then we would. So 2 tan A over 1 minus tan squared A. Wait, so 2A and we have 2 theta. So 2 tan theta, so 2 tan 3 over 4.
No, tan theta is 3 over 4.
Oh, so 2 times 3 over 4.
Yeah.
Over 1 minus 3 over 4 squared.
Yep.
So,
what answer do you expect to get?
I'm not sure.
Okay.
I got 24 over 7.
Yes. Because
yeah, it said show that.
Yep. So basically, I'm lazy and overconfident, so I never bother putting anything in the calculator. They told me it's 24 over 7, let's see. Big picture. So I'm not sure if this is the best way to go about this, but I had to do it this way. One line cuts the other angle of the other line in half, and so that's theta. I could have said that's half or something, but I'm using whole numbers. This one, for every one right, it goes 3/4 up because that's the gradient. So this one goes through 0, 0. This one goes through 1 3/4. And so change in y over change in x is literally what tan is. And so that is 3 over 4. Tan theta is 3/4. That's a 1 marker. Then the second one, tan 2 theta, is the other one, is the other gradient. Tan 2 theta is, in terms of tan 1 theta is using this formula. Tan theta is 3/4, and so we sub that into our formula. And so this gradient is 3/4, this gradient is 24/7. Any questions about that?
No.
Yeah. Trig, man. Okay. We didn't get to this thing. Use the identity to show that this, so that's proving it. For this one, let B be equal to A. And so instead of cos A plus B, what do you get? You get cos A plus A. Wherever there is a B, what do you replace it with?
A.
Yep. And so when you do that, you end up getting this thing. And then you've got some geometry. 4 cos 2x. They're both equal to y. You make them both equal to each other. You use this identity up here that they just gave us, and you change it into yeah. Anyway, we got almost all of it. Double angle formulae.
Half.
I'm happy with that. So what is that? 7.3. So next, do we do 7.4, which is something like solving equations with double angle formulae? Or something else?
Yeah, sure, we can just continue on with this.
Alright, it's a lot. Any questions for me in general?
No.
And how are you finding this trig stuff?
It is hard, but
I think it's the hardest thing in A level, to be honest, in both years. Yeah. Alright, well done, kiddo. You're doing great. Hang in there. Have a good week, and I'll see you next week.
Yeah, you too. Bye.
Thank you. Goodbye.